Alright, today we're going to be talking about right triangle trigonometry. Right triangle trigonometry. So before we begin, let's talk about the right triangle. As you can see here, we have a right triangle. If we were to measure this right here, the two legs of the triangle, this leg and this leg, form a right angle. So this little mark here means it's a right angle. Now if we have two rays, one going this way and one going this way, they form an angle. So this angle is 90 degrees. Okay? Now there's a special type of triangle in which the angles are 90, 60, and 30 degrees. And that's the triangle we're going to talk about today. So if we have a triangle with these angles, all of these add up to 180, which is the sum of the degrees of the angles in a triangle. If we're given the length of the hypotenuse, let's just say it's 2, 1. The side that's opposite the 30 degrees will be half of the hypotenuse. Okay. If we take the side that's opposite the 30 degrees and multiply it by the square root of 3, we get the longer leg. So in this equation, the hypotenuse equals 2 times the shorter leg. And the longer leg equals square root of 3 times the shorter leg. And I'm abbreviating. So again, if we take the shorter leg, which is a half, we multiply it by 2, we get the hypotenuse, which is 1. If we take the shorter leg, which is a half, and multiply it by the square root of 3, we get the longer leg. So let's look at another type of triangle. Okay? So here again, we have a right angle, and that's 90 degrees. This time each of these angles are equal, and they are 45 degrees. Okay, so if the hypotenuse is 1, each of the shorter legs is going to be square root of 2 over 2. So the relationship between the hypotenuse equals, and the shorter or the leg, there's only one leg and they're both the same, equals the square root of 2 times the leg. Okay, so the hypotenuse, which is 1, equals the square root of 2 times the leg. So if we take the square root of 2, multiply it by the leg, we square root of 2 times 2 over 2, which is square root of 4 over 2, which is 2 over 2, which is 1. Okay, so if you took a ruler and you measured this length and it was square root of 2 over 2 millimeters, and this angle was 45 degrees, then you know this would be 1 millimeter. And this would be square root of 2 over 2 millimeters. Okay, so why are those relationships special? The reason is when we're using trigonometry, we have three functions: sine, cosine, and tangent. If we wanted to calculate these values, we could easily find them using this information. So if you remember from the last slide, if we had a triangle like this, that's from the previous slide, we can calculate the sine, cosine, and tangent of all of these angles, 45, 45, 60, 30, by using right triangle trigonometry. So how do we find sine, cosine, and tangent? I used a mnemonic device. Sa, ka, toa. Okay? So what does that mean? Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. So let's just say we wanted to calculate the sine of 45 degrees. Sine is opposite, which is this. Okay, opposite, the side that's opposite the 45 is this side, and the hypotenuse is 1. So sine of 45 is this. Similarly, cosine of 45 is adjacent, which is this one right here, over the hypotenuse. So those are the sine and cosine of 45. Now if we want to figure out what the sine and cosine of 30 are, we'd use the following triangle right here. So why don't we do that in a different color? So the cosine 30 equals, and that's in degrees, cosine of 30 is adjacent over hypotenuse, which is the square root of 3 over 2 over 1, which is just the square root of 3 over 2. That's the cosine of 30. The sine of 30 is 1/2, right? It's opposite over hypotenuse. Opposite 1/2 over 1, which is just 1/2. Okay, what about 60? So the cosine of 60 equals adjacent, which is 1/2 over 1, which is just 1/2. And the sine of 60 is opposite, which is the square root of 3 over 2 over 1. So square root of 3 over 2 over 1 is just square root of 3 over 2. That concludes our lecture on right triangle trigonometry.